Hello everyone, and we're continuing our discussion into IFR conditions. What we're going to do now is talk about the causes of IFR weather. And it's pretty obvious that what causes IFR is low ceilings and low visibilities. So we're going to look at low ceiling first. And we're going to look at the definitions of ceiling. You've seen these before. Then we're going to talk about the different methods by which clouds form. First off, the definition of a ceiling. There are two definitions. The first one is the height above the Earth's surface of the lowest layer that's reported as broken or overcast. The second definition we also discussed earlier was the vertical visibility into an indefinite ceiling. So if you see in the METARs, broken, overcast, or vertical visibility, you have a ceiling. And vertical visibility, I think I mentioned this before, but years ago they used to measure vertical visibility using balloons. And when the balloon disappeared from the observer's view, they could time they take the time how long it took to ascend until the time it disappeared. And knowing the rate of ascent, they can figure out the distance. They use black and orange balloons. They don't do that anymore. Now there's an algorithm on the AWOS and ASOS machines that looks at the scattering in the lowest layers of the atmosphere and also the visibility to determine if there's a vertical visibility.
Of course, vertical visibility is a ceiling, and when you have vertical visibility, we call it an indefinite ceiling. In other words, there's no definite cloud base. And the definition of definite ceiling is a ceiling classification applied when the reported ceiling value represents the vertical visibility upward into a surface-based obscuration.
Okay, moving on to the cloud formation, how clouds form. There are four general ways. There are many ways, but these are kind of the four categories of methods for cloud formation. We're going to look at the first one in this video, and that's cooling the air to saturation. So there are many different ways which air rises and cools. Convection, meaning vertical motion as a result of an unstable atmosphere. The air rises, thermals, and finally when the temperature equals the dew point, you get clouds. Also, topography causes air to rise, and you get the formation of clouds. And then also weather systems in the atmosphere cause convergence and divergence. When you have low-level convergence and upper-level divergence, that causes typically very deep layers of clouds. And then, of course, fronts act as lifting mechanisms, and the air rising up over fronts tends to condense and produce clouds also. So you know that the rate at which air cools is the dry adiabatic lapse rate if it's forced to rise, or if it rises on its own. As the air goes up, it expands and the temperature drops. And the dry adiabatic lapse rate is 5.4 degrees Fahrenheit per 1,000 feet, or 3 degrees Celsius per 1,000 feet. Not a lot of people realize that the dew point also has a lapse rate, and that's about 1 degree Fahrenheit per 1,000 feet, or about a half a degree Celsius per 1,000 feet. It's less than the dry adiabatic lapse rate, of course. The rate at which they converge is the difference between those two lapse rates. For the dry adiabatic lapse rate, it was 5.4 degrees Fahrenheit per 1,000 feet. The dew point lapse rate was 1 degree Fahrenheit per 1,000 feet. The difference is 4.4 degrees Fahrenheit per 1,000 feet. If you want to do it in Celsius, in the METARs, we have Celsius temperatures, so it's 2.5 degrees Celsius per 1,000 feet. So this is how you figure out cloud bases, especially for cumulus clouds. It does not work as well for stratus clouds. Stratus clouds usually come from another location. Cumulus clouds usually come from the ground very close to where you see the cloud. What you do to figure out the cloud base, take the temperature, subtract the dew point, divide it by 2.5 if you're working in degrees Celsius, and then multiply it by 1,000, and that'll give you cloud base. So here's an example of Grand Forks where the temperature is 25 and the dew point is 20. That gives you a temperature dew point spread of 5. 5 divided by 2.5 is 2. Multiply it by 1,000 and you get 2,000 feet. And that's what it shows in the METAR. So this is the calculation that we've just done. 2,000 feet is the answer. Remember, this only works for cumulus clouds, does not work for stratus clouds, because stratus clouds, the air comes from a different location. Usually cumulus clouds come right from the ground, right where you're standing, and that's where you're making your measurement. So the interesting thing here is that the height of cloud base depends upon the temperature and the dew point. In other words, the spread at the surface. And I'd like to mention that as the day progresses, that spread increases. A lot of times the dew point doesn't change too much, but the temperature does increase towards the afternoon. As a result, what you will find with cumulus clouds, they start out rather low, but then as the day progresses and the temperature and dew point spread increases, the height of cumulus clouds will actually increase as the day progresses. Check it out in the summertime sometime, you'll see that. Another interesting fact is that usually moisture is higher along the Gulf Coast and the East Coast of the United States. As you move towards the central part of the United States, the dew point decreases. You get farther from a source of moisture. So as a result, what you'll find is cloud bases generally increase as you move towards the central United States. That's what this shows. It shows for a particular day if the temperature is the same all across the United States, and that's not always the case. But if we just said that the temperature is the same and the dew point decreases as you move into the mountains, you notice that the spread increases, and as a result, cloud bases also increase dramatically. As a matter of fact, you'll find very high cloud bases over mountainous areas because it's so dry in those locations. Mountainous meaning the Intermountain West, such as Nevada, Montana, Idaho, Wyoming, Colorado, New Mexico, where you're far away from a source of moisture. And with as air is forced to rise, if it's forced to rise, typically you're going to get stratus clouds. If the air is unstable and it rises by itself, typically you get cumulus clouds. That's the first section on cloud formation. There's another video on the 3 other ways that clouds can form.